Let's take a look at how to do some 2D sketch mechanism motion dynamics. And a great example is a 4-bar linkage. Uses the slot tool here. Love this. Draws nice slots the same size, and they're treated as rigid bodies. Let's put a fixed constraint right here on this endpoint. And then I can just drag that motion, and that's moving the way that I want. Now let's do a motion study. We'll put a motor on the driving link. When I add a rotary motor, by default it goes on a body. What we want to do though is not put it on the body, but instead put it on the arc, and that's going to put it on that joint that's connecting that link to ground. How about a 60 RPM? That's going to give me one full turn every second. We'll set the animation time to 4 seconds, which should give us a nice steady state behavior. And then let's put on a load plot here, and what we see is if we change to torque and we click on the motor, 0 torque. That's because at this point there's no body loads on the part. The dynamic solver has not kicked in yet. So the way we do this is by turning on gravity. Once we enable gravity, it will force the dynamic solver. And then once it reruns, we can now see we get that oscillating torque. And this would be the motor torque required to create that motion. If you zoom in on the plot just by dragging, you can zoom right in and we can pick off what those magnitudes are. Double click to zoom out, and we see we get a nice steady state behavior there. Let's put one more load plot on, and this is just going to be a force plot, and I'll pick the slot over here attached to ground. Now if I just pick the slot by itself and no second pick, that's going to put it at the joint connecting to ground. If I add another selection, that will give me the reaction force at the joint between those two slots. So this is great. We now have a graph of the XYZ and magnitude reaction forces, as well as a graphical force arrow, and that's looking pretty good. So I have some pretty good confidence that I'm getting some dynamic results here. That's great. What if I change the mass of one of these links? Down in the motion toolbar, we can change the mass for the 2D link. I'll change it up to 250 kilograms here. The only hitch is that the solver doesn't think it needs to recalculate. So just as a little trick, just go and jiggle the timeline a little bit, and that should force the recalculation. And now watch those magnitudes update. In fact, our torque plot, we need to double click there to resize the scale. Go zoom in a little bit, and sure enough we can see that our torque and reaction forces have increased with the increased mass of that middle link. So some pretty good dynamic results.